Welcome there, Mr. Sutton here, bringing you the BC Calculus 7-1 Part 2 homework solutions on derivatives and integrals of series. On this problem, we're given this function here defined by a sigma, and we want the first four non-zero terms in general term for the integral of this thing from 3 to x. Well, let me start by writing out the original. And let's see, I need four non-zero terms and I'm integrating, so if I just write out four non-zero terms for this, that should be enough. So my first term is just all this stuff to the 0, which is just 1. And then for the next term, we've got, let's see, this is n equals 1 now, so this is going to be negative 1/2 times x minus 3, invisible first power. Next, I'm essentially just multiplying by negative 1/2 x minus 3 each time. So my next term is going to be plus 1/4 x minus 3 squared, then minus 1/8 x minus 3 cubed, and that's enough terms to take the integral. So let me just add my general term there on the end. Now it's time to take the integral of this stuff from 3 to x. Now just thinking ahead a little bit, when I take the antiderivative of all of this stuff and plug in this lower limit of 3, not everything is going to get zeroed out. So I'm actually going to have to write all this out in an evaluation box with t, my variable of integration. I can't just go straight to the answer right away. So this 1, that's going to become a t inside my evaluation box. For this next thing, I'm bumping this up to an exponent of 2 and dividing. So I've got negative 1/4 times x minus 3 squared. For this next one, this bumps up to a 3. Dividing, I have plus 1/12 x minus 3 cubed. And for this next one, this bumps up to a 4, so this is negative 1/32 x minus 3 to the 4th. And for this last one, and by the way, I've got t instead of x. I was saying x, but really should have been saying t all along. For this next one, we've got, let's see here, dividing by n plus 1. So I have negative 1/2 n over n plus 1 times t minus 3. I remembered this time, t minus 3 to the n plus 1. And then we have all of this stuff being evaluated from 3 to x. So plugging in x, first of all, that replaces all the t's with x's. And then I'm going to subtract 3 plugged into this t here. That gives me this negative 3 out in front. And then, let's see, this 3 is actually going to zero out all these other parentheses that have t minus 3. So really, this minus 3 is the only thing I'm getting by subtracting all this stuff with 3 plugged in. For this one, I'm trying to figure out the first four non-zero terms in general term for a power series of the integral of this function down here. I'm going to start by writing out the original function. Plugging in 0, all this stuff to the 0 is just going to come out to, let's see, this is even x to the 3 times 0, so it's all coming out to just 1 for that first term. Then we're going to have negative 1 times x to the 3rd. And then we're going to have, let's see, plus x to the 6. And this is basically a geometric series. You're just multiplying by negative x cubed each time. So my next term is just going to be negative x to the 9th. And I'm taking an integral, so I just need four non-zero terms to start here. Let me just put the general term in at the end here. All right, now to take the integral. Now just thinking ahead a little bit about whether or not I actually need my evaluation box, when I take the integral of this thing from 0 to x and I end up plugging 0 in for the antiderivative of all these things, well, my antiderivative, I'm going to have an x, I'm going to have some other things with x, so that 0 is actually going to zero out all of these terms when I plug it in, which is all to say I don't need my evaluation box. I can actually just skip to the answer that has the x's in it, because I know I'm going to be zeroing out all the terms by plugging 0 in for x. So just skipping to the answers, we have this one becoming an x, and then this next one, this becomes minus 1/4 x to the 4th, plus 1/7 x to the 7th, minus 1/10 x to the 10th. And then over here, this is going to be a negative 1 to the n over, let's see here, this is going to be, this bumps up to 3n plus 1. So this is going to be over 3n plus 1 times x to the 3n plus 1. And that's it.
For number 3, we essentially want to take the integral from a to x of this function here, where a is 0. So let's write out the original function first. And since they want the first 4 non-zero terms in the general term, we're going to write out 4 of these. So first term is going to be 1 if you plug 0 in for the n's. After that, we've got 2x. And after that, plugging in 2 for the n's, we've got 4x squared. And we'll do one more, 8x cubed. And then our general term, which is just 2 to the n, x to the n. Okay, let's go ahead and take the integral of this expression from 0 to x. Now, since we're taking the integral from 0 to x, and when we put that in our evaluation box, we're going to be plugging 0 into a bunch of things that have variables in them. So that whole second part of our evaluation at the end, we're just going to be subtracting 0. So I'm just going to go straight to the antiderivative of these things with x plugged in. So we've got x for this 1 here. And now keep in mind I'm skipping the step where I turn all of these into t's and plug in x and then 0. Next we have, this bumps up to a 2. Dividing by that we have x squared. Next we've got 4 over 3, x to the third. And we've got 8 over 4, or 2, x to the fourth. And then for the general term, we're going to have 2 to the n over n plus 1 times x to the n plus 1. And there we go. For number 4, we're given this function, and we want to write the first 4 non-zero terms in power term of basically the integral of this stuff here. So let's go ahead and write out the original function, and then we'll integrate it. So let's see here. First term, we've got 3 times all of this stuff to the 0 power. That's a first term of 3. Next, plugging in 1 for n, we've just got 3 times x minus 1 over 2. And then we'll plug in 2, so 3 times x minus 1 over 2 squared. And then we'll do one more, which is just all of this stuff, but with the third power instead of the second power. And we'll write our summand here as the general term. Next, I'm going to go through and integrate all of this from left to right. And our a value here that we're plugging in for our lower limit of integration is 1. So since this stuff is not all going to zero out when I plug this in, I'm going to go ahead and actually do my evaluation box. So I'm going to first write my antiderivative with the t's in them, because this is integrating with respect to t, and then we'll figure out what happens when we plug in x and 1 for the t values. So going from left to right, I'm going to write this as 3t. Next, this is going to be, let's see, we have a power of 1 that we're dividing by, or actually 2, so this is going to be 3 over 2, all of this stuff to the second power. But then we're actually dividing by the inner tail here, and we've got to be careful. We really have an interlinear function with a 1 over 2. So I'm dividing by the 2 as part of my reverse power rule, but then I'm dividing by a 1/2 as part of my inner chain rule here. All right, moving on. We have, this is going to bump up to, we're on this one here. This is going to bump up to a 3. So we're dividing 3 by 3, but then we're dividing by the 1/2 inside. So this becomes a 2 out here times x minus 1 over 2 to the third power. And then for the next one, this bumps up to a 4. So we're dividing 3 by 4, but then again dividing by 1/2, multiplying by 2. So that's going to be, let's see here, 6 over 4, which is 3 over 2. And this general term here, we're going to have 3, well actually this will be 6 because we're dividing by 1/2, so 6 over n plus 1, all of this stuff to the n plus 1. And then we're evaluating that from 1 to x. So when I plug x in for all this stuff, all that happens is I replace the t's with x's, like so. So pretty much spitting image with x replacing t. But now I also have to plug in and subtract 1 with all this stuff. If I plug 1 into all these terms with the t minus 1s in them, it's actually very convenient. Those all go to 0 and cancel out. So we really just have 3 times 1 to worry about, and we'll be subtracting that. So we're going to end up with a minus 3 at the beginning of all this stuff if we put things in increasing order of exponents. On this problem, I'm given this f of t function, and we're told that g of x is the integral from 0 to x of the f function. We want the first 4 non-zero terms in general term for g of x. Okay,
Well, it would help if we had a power series for f of t. Now, f of t, the key on this one is realizing that this is a geometric function. We have an a1 value of 4. We have an r value of negative t squared, because that's what's being subtracted from 1 down there. So then I'm just going to generate this series doing my little geometric dance here. So I can say f of t equals 4 minus 4t squared plus 4t to the 4th. We're just multiplying by negative t squared each time. And then minus 4t to the 6ths. And then my general term, in general, I'm going to have a negative 1 to the n. I'm going to have a 4. I'm going to have a t to the 2n. There we go. So I have to take the antiderivative of all this stuff now. Now thinking ahead, when I actually integrate all of this, this first term is going to be 4t, and I'm going to be plugging in 0 for my lower limit of integration. That's going to zero out my first term and really all the rest of my terms. So I'm actually just going to skip straight to the answer instead of doing all this in an evaluation box. So my first thing I'm going to write is this just becomes 4x. I'm just plugging in x to my antiderivative. And then this next one, I'm going to have, let's see here, integrating this bumps up to a 3, so this is negative 4/3 x cubed. This next one will be plus 4/5 x to the 5th. This will be minus 4/7 x to the 7th. And over here we're going to have plus, let's see, negative 1 to the n. We've got a 4 up there. We're dividing all of that out in front by 2n plus 1, and this is x to the 2n plus 1.
For number 7, we're given a function defined by a series, and we want the derivative of that function. And it looks like all the answers are in expanded form, so we should probably start by just expanding this right off the bat and taking the derivative term by term. So let's go ahead and do that. So our first term, when we plug 1 in for n, that's going to be x to the 2nd power over 1 factorial, so just x squared. Then if we plug in 2, we're going to have x to the 4th over 2 factorial, or just 2. And then plugging in 3, that's x to the 6th over 3 factorial. And then finally x to the 8th over 4 factorial. We could keep going. We could actually write out the general term as well. But if you take a look at these answer choices, we have different stuff for the first 4 terms on all of these anyway. So if we figure out the derivative of this stuff, we don't really need to worry about the general term on this multiple choice question. So going term by term, we've got 2x for the very first thing. And right off the bat, it's looking like answer choice D is a good answer. But let's just keep going just to be on the safe side. So this next one, multiply by 4. We've got 4 over 2, which is 2, x to the 3rd. So far, D is still looking pretty good. And then over here, multiplying by 6. We actually have a 6 down here. So this is just x to the 5th. And then finally over here, multiplying by 8, we have a 24 down here. So this is going to be x to the 7th over 3 if we reduce that. And then we could keep going, but I think it's pretty clear answer choice D is the one we're looking for.